Hello. Today we are going to cover one project which include embedding of data in image. Here this is known as invisible watermarking. Although embedding is of two types, visible or invisible. So we concentrate or most of the work done in research is for invisible watermarking. One can also name this as data hiding. Data hiding is also same kind of watermarking if we are doing this in invisible way. So here we implement two kind of technique. First is chalk tick and another is canny. Canny is a general algorithm used for age detection. It's a kind of standard algorithm. While chalk tick is a function which jumbled image position as per the function and reverse back image back to its original state. I'll see you or I'll show you this when we run the function. So the basic thing which we are going to cover in this project is Choptic function, canny algorithm, embedding, extraction, and spatial attacks. Here spatial attacks tends to some kind of filter or noise attacks. So coming to our project part, I have developed this work on MATLAB. In order to run this, just type edit edit on the command window. It open one separate window which is known as editor window. Just click on the file button, open open the code which I have provided you. You have to open this function with the name compress underscore GUI. So here is the code of that function. It's a GUI code used for the interface of user. So to run this function, just click on this green button or simply press F5. This open one window. Now here are some buttons which I have provided. These all are buttons which are based on uh, some previous work for, and the name of that work I name as base work paper. Filter attack and noise attack are the spatial attacks, while proposed work is known as Choptic and Kenny algorithm work which I have proposed, or we can say it as our work. Then the filter attack and noise attack apply on the same proposed work. So start with the image which is act as a carrier image. So select one image. Here I select. Now click on the base paper button. It generate an output with embedding image and extraction image. These are the SNR, PSNR, and extraction rate are the evaluation parameters based on the on this base paperwork. It means after embedding the signal to noise ratio is 56.0854 dB. Similarly, PSNR peak signal to noise ratio is 32.037, and extraction rate is kind of uh, data which we extract after embedding, means the amount of watermark which we extract after embedding is 85.7143 percentage. Fine. In similar fashion, we can click on the proposed work which will run the Choptic function and the canny algorithm. So just click on it. Here we get a list of images. List of these images are nothing except the jumbled images which we obtained after applying a Choptic function. So the logic behind this I'll explain you in detail. but these number of images are the jumbled images which we obtained uh, after Choptic function. So what happened over here, that jumbling of these pixel value happened in each iteration, and once we get original image after number of jumbling. So, I give you an example that for a 128 cross 128 image, it means number of rows is 128 and number of column is 128. You need to take around 105 iterations to get back the original image. If lambda value is 1, lambda, what is lambda value? It's a kind of the function or the name Choptic function is depend on a matrix. This is the matrix 1 1 lambda lambda plus 1. So the lambda value is a kind of integer number which is uh, which range from 1 to n. I never use this n term, that what is the last number. I generally use 1 2 3 5 till 8, because as per the lambda value, number of iterations get increased. So in order to increase the complexity or the security of image, you can increase this lambda value, but it increase time, execution time as well. So be patient when we increase the lambda values. If you are going to check that we have got this number of iterations regularly, so each time we are getting a new set of image or new set of pixel arrangement by Choptic function. So I explain you proposed model work. So this is the proposed model work. Okay, uh, let's zoom it. Okay, what's going over here? We have an image data set, then we take one image which is no which I can named as an original image, then apply a Choptic function which simply gives a new position as per this lambda. Suppose we have a position of 1 1 and lambda is 1, then 1 1 1 and 1 plus 1 2. So the matrix become 1 1 1 2. Now multiply this 1 1 1 2 with the xy or the current position, then you get a new position for that pixel value, and in similar fashion multiply with the other pixel value, multiply with other pixel value positions, and each time you will get a new position. So after first iteration of Choptic function, we get a new image, means a new set of pixel. Then embedding position means watermark which we are going to embed in the image. We just use binary embedding, means watermark may be in form of text or maybe in form of image. So convert any of this form in vector of a binary consecutive single dimension vector, or vector is already in single dimension. So let's say we have 100 bit, then position is 100. So for the first bit we apply canny algorithm on this new image. We apply canny algorithm on this new image, then it divide or it gives an output of 0 1. 1 represent the age position of the image and 0 represent a non-age position. So whole set of image is divided in two region, age and non-age region. Now further create block in the image. We set a block of size 2 cross 2, means we have a if we have an image of 16 cross 16, then it will divide whole image into 8 cross 8. Sorry, number of uh, blocks in row wise is 8 and number of blocks in column wise is also 8. So total 8 cross 8. It's around 64 blocks. Now each block is further identified as age region and non-age region, where in age region block we embed 3 bit, while in non-age region block we embed 1 bit only, and then we fuse that block or we put back that block in same position. So this is how we are doing embedding. Now what how we do uh, or how we replace these 3 bit. So for this I just explain you by paper. Yeah. uh, Age and non-age, non-age pixel and age pixel. So please read this one, okay? And while reading, I'll explain you each and every step. Let us suppose a 2 cross 2 block. So A having 4 pixel as and each pixel is of 8 bit. Then this is the 8 bit pixel values in binary. Now corresponding to P1, P2, P3, P4. P1 to P4 are the name of the pixels. This let P1 is this one, and similarly P2 is this one, then P3 is this one, and last one is P4 is this one. So and the secret message or the watermark bits are this. Okay, I don't know how this comes. So the image A is considered to be a 4 pixel block. Let us assume that based on the canny age detector. Now as we have already applied a canny algorithm on the before blocking the image, so we know that which pixel is representing an age region and which pixel is representing an non-age region. So here we assume that P2 and P4 are age pixels. So once P2 and P4 are age pixels, then we put this information in P1 pixel, because after jumbling or after embedding, some bit might get changed, and they will reallocate or itself from age region to non-age region or non-age region to age region. So P1 is going to remember this, that which one was age and which one was non-age. Thus the pixel P1 receives the new value, this one. This last 3 bit of this is 101, while P1 last 3 bit before this embedding operation was 010. Now embedding of age region was done in this way, that further we assume that the value of parameter x is 1, that of y generated randomly by Chokri from this. Now we XOR the y bits of message with the y MSB bit of pixels. So here what we do, or what this work do, that let's say we are going to embed this 010, and P2 is the age pixel. So we just do XOR operation of 100 with this 010, and the resultant of this XOR operation of these 3 bit is stored in the least significant value or the position of same P2 pixel. So the XOR operation of message bit with the MSB bit of the pixel or the age pixel um, result is stored in the least significant bit of the same pixel. And while for non-age we embed one bit only, so the next one bit is 0. 0 is XOR with this 1, and the resultant of this is stored in the least significant position of this. In similar fashion, P4 is again an age position, so the next 3 bit of this message is XOR with the most significant bit of this P4 pixel, and resultant of this XOR is stored in the least significant bits of this P4 pixel. This is how we are doing embedding in our model, and we put back that block and embed image. Finally, we come back to the chalk tick, and it going to iterate itself till it do not get its original form. So the output of the resultant image or the embedded image is again same, which looks same, although this image is embedded image. While I do both operation embedding and extraction by just single click, so the result, and so the next image is the extraction image. We are not going to judge this because of invisible watermarking, but what we got over here is that signal to noise ratio and peak signal to noise ratio and extraction rate is higher as compared to the base paper work. So this is how we do work, or we do embedding. Extraction process is just reverse. Here we take embedded image, chalk take function, then chalk take function make necessary movements or jumbling in the pixel position as per the chalk take matrix or lambda value. Then extraction, then apply 2 cross 2 block. Here we are not going to apply canny algorithm, and the 2 cross 2 block first pixel of that 2 cross 2, let's say P1, will specify which one is age and which one is non-age. Then age region gives us last 3 bit as a message bit, while non-age region give us last bit as a message bit. Then we can go keep on combining all these bit in a single vector, and this is how we do extraction of watermark. So I hope this helps you for embedding and extraction. I show you some more code part of this work. Just click on this button. This is a guide button where we have design our model or a GUI window. So I just click on this button. You can check later in similar fashion, or you can check other button in similar fashion. Just click right click on this proposed work, click on view callback and callback. Here it redirect us to the calling function. Here I call arnol cat map function, which is a proposed method call. So this is the function which we have use for our proposed model, and this was the matrix. This was the matrix. Here I use lambda value as 2 instead of 1. I use lambda value 2. So what happen if I use lambda value 2? Then the matrix become this: 1 1 2 2 plus 1 3. So lambda so the Choktic matrix become 1 1 semicolon 2 3. So it's 1 1 2 3. Now this get multiply, and I make a loop of 450. I hope that within 450 iteration it get back to its reverse or the original image. So here we have to all the operation for the embedding, and extraction function is also there. We do this binary to decimal conversion. So embedding and extraction both done is in this function, and these are the peak signal to noise ratio and signal to noise ratio. This is ETA extraction rate, which we are going to cover. And arnol cat map extract was the calling function which extract data. It's a kind of extraction function, and this one is embedding function. I hope this video and this program help you out for developing or understanding image watermarking, invisible data hiding. Thanks for watching this video. To know more about it, you can contact me on the websites where you have got my video. Thanks a lot.